All right, so now that we've discussed what a polyhedron is and introducing the idea of just talking about some solids, the reason why we want to do that is we want to get into surface area and volume of these solids. One of the more useful things that you'll get from this class is surface area and volume, but only in terms of leaving high school and being able to use it in the real world. Especially when you become a homeowner, surface area and volume will come up all the time. Surface area in terms of painting or replacing floor, if you're going to do any tile work, things like that. Volume could be anything from hot water heaters to your pool, if you end up owning a pool, or whatever that you need to fill up with a liquid, right? Is what we're talking about with volume. So the next couple of units are going to be about surface area and volume, and we want to get into that with these solids, with all different kinds of solids, and how to kind of think through how to find the surface area and the volume. It can be very, very useful when it comes to buying materials for whatever it is that you need to do. For surface area, we're going to talk about spheres first, only because the formula is a little bit odd where it comes from. Obviously not a polyhedron, right? Remember, polyhedron's got polygons for its sides, and a sphere doesn't have any sides, right? So a sphere is just a ball, is what we're talking about, right? So here you see a picture of a sphere. Some things to know about a sphere, some definitions that you want to know. A sphere, the geometric definition of a sphere, it's a set of all points in a space that are equidistant from a given point. Now, it sounds a lot like a circle, right? So here's a circle with a center, and the circle is all the points that are equidistant from that center, right? We can draw a radius anywhere, and those points on that circle are going to be equidistant. We talked about that a lot before. A sphere is the same thing, right? Where it has a given point. If I can draw it in here. And the sphere is all the points that are equidistant from it, right? But it's three-dimensional. It goes in 3 dimensions now instead of just 2 dimensions. So you kind of get this solid ball, right? That becomes a set of all points in a space, not in a plane, but just in a space. And so, there we go. So since there is a point where all the points are equidistant to, then it's going to be called the center, just like it was for a circle. The center for this sphere might be right there. And then, of course, it's going to have a radius, just like a circle does. Again, the radius can be drawn anywhere. It can be drawn anywhere three-dimensionally. Up, down, left, right, at us, towards the screen, away from the screen. Lots of different ways you can draw a radius, but it's going to be in a three-dimensional space, right? And same thing, and it's the distance from the center to any point on that sphere. Now, it's also a segment, just like we talked about with circles. Radius is a segment or an actual numerical distance. Same thing with a sphere. It could be an actual segment drawn from a center to a point, or it could be the actual distance from the center to that point. And then, of course, it's going to have a diameter, which is just kind of the same as a radius, only this segment is a kind of a chord, right, where the endpoints need to be on the sphere itself. And go through the center, right? So that's going to give you, still going to have a diameter for a sphere. Okay, just some vocab for you. Radius is pretty big deal because if you're talking about the surface area of a sphere, how to find it, right? So surface area is kind of about how much paint would it take to paint a ball, or how much paper would it take to wrap a ball, right? If you could wrap it in wrapping paper without any of the corners sticking out or whatever, like you normally do if you've ever tried to wrap a ball. If you haven't, wait till you have kids. But the idea is that you want to kind of paint maybe around the center of it and then kind of extend that paint out, right? So if you need to go around the center of that sphere, then you're kind of talking about, how much area or how much space the outside takes up. I don't know, I'm trying to get you into a thought process that starts thinking about area, right? Since surface area is in the name, since area is in the name of surface area, we want to think about area. So if I go around the ball, then I need the area of a circle, right? And so we start surface area by going around the ball, and that area is just the area of a circle, pi r squared. But obviously, we're going to stretch that area out, top and bottom. So we need more. We need more than just pi r squared. How much more? Well, there's not really a lot of rhyme or reason to it. It just ends up being 4 times more. Okay? And so the surface area of a sphere just turns out to be 4 pi r squared. Now, this is a formula that you just need to know. You've got your notes there, so make sure you write that down, and that's going to be the formula that we use. Quick conversation about paying attention to directions on standardized tests and things like that. If you're looking for exact or approximate surface area, it all depends on what you want to do with that pi, right? So, for example, if the sphere has a radius of, say, 2 inches, then this becomes very easy. We just go 4 pi times 2 squared. And so we go 4 pi times 4, which will give us 16 pi inches squared. It's still an area, so the units are square units. This becomes your exact answer because pi's in there. We haven't rounded anything off. Or if you want an approximate answer, you go ahead and multiply the 16 times the pi, and you would get 50 point, and then you'd want to round it, right? So 27 inches squared. And so this would be your approximate. Okay? So just pay attention to your directions and what kind of answer you want to be giving. I think typically what you're going to find here in these assignments is that we're going to want approximate, we take either, right? We really take either approximate or exact answers. Most of your answers given are going to be approximate probably, right? So just pay attention to how the answer is given in terms of when you're checking your work, okay? But anyway, 4 pi r squared is the formula that we want to use. So just showed you a quick use. Go ahead and stop the video, find the surface area of this sphere. Go ahead and give the exact and the approximate answer. You can check your work and we'll move on from there. Okay, so surface area of a sphere, first thing you want to do is grab the formula. So 4 pi r squared. Why 4? I don't know. Just the way it kind of worked out. The radius is 8, so we're going to want to square that. So we go 4 pi times 64, which gets us into 256 pi square inches. This would be your exact surface area, but you probably wouldn't walk into a Lowe's or a Home Depot and say, hey, I need enough paint to cover 256 pi square inches, right? They wouldn't know what you're talking about. So you'd want to multiply that out and get 804.25 square inches, and that would mean more to someone working at Home Depot or Lowe's, right? Because this is going to be your approximate surface area. Okay, and there you go, just a direct use of the formula. Okay, all right, could work backwards, knowing the surface area. Surface area of a sphere is 20.25 pi square centimeters. What is the diameter of the square? So it's multiple choice standardized test question here. So if we're talking about the surface area, we want to grab that formula, 4 pi r squared. And it turns out that this is our surface area. So whether you use SA for surface area or S for surface area, it doesn't really matter. But we're going to plug the 20.25 pi in for that. And then that's what you're going to want to solve. You're going to want to solve for r. Now, it asks for the diameter, so we're going to solve for the radius, and then just double it. Not a big deal. So we'd want to divide the pies out first, or recognize that since there's a pi on both sides, those are going to divide out. And then we can divide 20.25 by 4 and get 5.0625. And then we'd square root, right? And so the radius is going to be 2.25 centimeters. But again, remember that it asked for diameter. So 4.5 centimeters, which gets us to an answer of B, right? So pay attention to your answer choices. Make sure you know what you're looking for. 2.25 is an answer choice for you, but that's not what we wanted, right? We wanted the diameter, not the radius. So you always want to be careful about that kind of stuff. Okay, a few more definitions for spheres. We talked about cross sections in the last video. We were introducing polyhedrons in solids. You can take a cross section of a sphere, and anytime you take a cross section of a sphere, and I mentioned in the video that we do this all the time, so we can create lenses, right? So if you take a cross section of a sphere through the center, so that point just popped up right there to show you that's the center point. If you take a cross section of a sphere through the center, you will create what's called a great circle. So this big guy right here is called the great circle. It's because it's the biggest circle that you can create with a cross section in a sphere, since it goes through the center. Okay? Now, once you do that, if you cross section a sphere and separate those two, you're going to create some parts of spheres. And if it goes through the center and it contains the great circle, and you separate those two halves, then you get two equal halves, and those are called hemispheres, right? Much like the Earth is separated into two hemispheres. A sphere can do that with a cross section, okay? We introduced that because very often you're looking at hemispheres instead of spheres, and we want to talk about how we might want to cover that with paper or with paint, right? If we have something decorative that's in a hemisphere and we need to paint it, right? And so think about it. Excuse me. Think about it. How would we go about painting this? Well, maybe we paint the rounded part first, right? And the rounded part is just half of a sphere, right? So the surface area of this guy is going to have to be half of that 4 pi r squared or 2 pi r squared. But that's not all. We also have this bottom part that we want to paint. Well, that bottom part's just a circle, right? So what's the area of a circle? It's just pi r squared. So then our formula turns into 2 pi r squared plus pi r squared. Believe it or not, those are two like terms. They both have pi r squared in it. So we could just add those together and make this 3 pi r squared. And that indeed is the formula for the surface area of a hemisphere. So it looks a whole lot like the sphere, just instead of a 4, we've got a 3, right? So we can just need to recognize when we're talking about finding the surface area of a hemisphere versus finding the surface area of a sphere. Now, here's something else that you'll see in standardized testing, is that sometimes they want everyone to get the same answer. So instead of using the pi button, they're just going to say, hey, why don't you just use 3.14 for pi? Because some people are going to use that. Some people will want to use the pi button. Some people will want to round out to more decimal places. So here we're just going to use 3.14 for pi, right? Total surface area of the hemisphere, right? We've got the radius there. Got this nifty little formula, 3 pi r squared. So we take 3 times 3.14, because that's what it says it wants us to use for pi. And the radius is 10, and so we're going to square that. So obviously 10 squared is 100. If you take 100 times 3.14, you get 3 times 314. You multiply that, and you get 942 square centimeters. Okay? All right, and that's all there is to surface area spheres. So check out the homework. Hopefully it won't take you very long, and we can discuss any questions next time if you have them.